Hey everyone, welcome back. Today, we're going to talk about the invisible engine that is powering, well, pretty much everything in our modern world. I'm talking about the breakthroughs in medicine, the AI in your pocket, you name it. It's a piece of software that's become one of the most important, most strategic assets in all of technology. So let's dive in and see how it all works.
So let me ask you a question. When you think about what makes the modern AI revolution possible, what comes to mind? Probably powerful computer chips, right? These huge data centers with rows and rows of servers. And look, you wouldn't be wrong. But that's not the whole story. Not even close.
You see, the real secret, the absolute game changer, isn't just the silicon itself. It's the software that finally unlocked the insane potential of that silicon. It's a platform that basically gave developers the keys to a whole new universe of computing power.
And that platform is called CUDA. Honestly, if you understand CUDA, you understand the entire journey from those clunky 90s video game graphics to the generative AI that is completely reshaping our world as we speak. It really is the secret sauce of modern computing.
So, what is it exactly? Well, CUDA, which stands for Compute Unified Device Architecture, was first released by NVIDIA way back in 2007. At its core, it's a platform and a programming model that lets software developers use a GPU, a graphics processing unit, for general-purpose computing. Think of it as the ultimate translator between a programmer's brilliant idea and the raw, number-crunching power of a graphics card.
Now, to really get why CUDA was such a massive deal, we have to understand the core problem it was designed to solve. And that whole story really starts with the tale of two very different types of processors that are inside almost every computer.
On one hand, you've got the CPU, the central processing unit. Think of it as a specialist, like a master craftsman. It has just a few incredibly powerful cores that are designed to do really complex tasks, one after the other, in a sequence. Then, on the other hand, you have the GPU. The GPU is less like a craftsman and more like an entire army. It has thousands of smaller, simpler cores that can't do super complex things, but they can all do a simple task at the exact same time. And this army architecture makes GPUs absolutely perfect for what computer scientists call embarrassingly parallel tasks. The best example? Video games. To draw a beautiful scene on your screen, the computer has to figure out the color of millions of individual pixels. A GPU can just throw a whole bunch of its little cores at the problem and calculate them all at once. A CPU would have to go one by one by one. It would be way too slow.
So this brings us to the million-dollar question. For years, scientists and researchers were staring at this massive parallel army just sitting inside their computers, totally underutilized, and they were thinking, man, I could use that for my research. But there was a giant roadblock. How in the world do you give orders to that army for something that isn't graphics, like a weather simulation or a financial model?
Well, before CUDA, it was a total nightmare. Seriously, developers had to perform all these crazy programming gymnastics. They had to pretend their scientific data was like a 3D texture, and then use really complex graphics languages like OpenGL to trick the GPU into doing the math they wanted. It was ridiculously hard. But CUDA changed everything. It created this beautiful abstraction layer that let developers write code in normal languages they already knew, like C++ and Python, and just have it run on the GPU. All of a sudden, this incredible power was accessible to everyone.
Okay, so we know CUDA is this magic translator, but how does it actually organize all the work? How does it command that massive army of cores? Well, it all comes down to a really elegant and simple computing model.
It's basically a four-step dance. First, the main CPU copies all the data it needs to process over to the GPU's memory. Second, the CPU tells the GPU to start running a specific program, which is called a kernel. Third, the GPU's army of CUDA cores executes that kernel, all in parallel, all at once. And finally, once the job is done, the results are copied back from the GPU to the CPU. That's it. Simple, right?
Now, to manage all this work without it turning into total chaos, CUDA organizes everything into a simple software hierarchy. And this hierarchy maps perfectly onto the GPU's hardware army.
Think about it like this. The entire job you want to do, say processing a huge image, that's called the grid. That grid is then broken down into manageable chunks called blocks. You can think of these like squads in our army. And then each of those blocks is made up of individual threads. The thread is the smallest possible unit of work. It's the single soldier in the army. Each thread runs on a single GPU core. So you've got this simple structure, grid, blocks, and threads, that lets a programmer easily command thousands of cores at once. It's brilliant. So for the first few years, CUDA was this really powerful but kind of niche tool, used mostly by scientists and researchers. But then, in 2012, something happened, something that created a big bang in the world of AI. It's what we now call the AlexNet moment, and it changed everything.
So you see the timeline here. CUDA comes out in 2007. For 5 years, it's quietly gaining traction. Then, 2012 happens. A deep neural network named AlexNet enters this major computer vision competition, and it doesn't just win, it completely demolishes the competition. The results were so shocking that by the very next year, pretty much the entire machine learning community had pivoted to using GPUs with CUDA.
And here is the absolute wildest part of the story. AlexNet wasn't trained on some government supercomputer locked away in a secret lab. Nope. It was trained on two off-the-shelf NVIDIA gaming GPUs, the kind of graphics cards you could just go out and buy. And they were programmed using CUDA. This was the moment that proved that world-changing AI research was now possible for anyone with a decent gaming PC.
This AlexNet moment was the proof in the pudding. It showed the entire world that this combination, deep learning algorithms running on the massive parallel power unlocked by CUDA, wasn't just a small step forward. It was a giant leap. This was the spark that truly ignited the modern AI revolution.
And ever since that moment, CUDA has just exploded. It became the bedrock for pretty much all modern AI, for sure. But its impact now stretches way, way beyond that. I mean, just to give you a sense of the scale we're talking about, the CUDA toolkit the software developers use has been downloaded over 20 million times. Think about that. This isn't some niche tool anymore. It's a massive global ecosystem of developers, all building their work on top of this single platform. And that ecosystem is accelerating basically everything you can imagine. We're talking drug discovery and bioinformatics, self-driving cars, incredibly complex weather simulations, financial market modeling, cryptography, Hollywood special effects, medical imaging like CT and MRI scans, and of course, the huge large language models that are everywhere today. And this is where we see NVIDIA's genius business strategy. CUDA isn't just a technology. It's their competitive advantage. It's their moat. Because CUDA only runs on NVIDIA hardware, that entire ecosystem of millions of developers and all the software they've built is effectively locked into NVIDIA's products. It is an incredibly powerful barrier that makes it really, really hard for anyone to compete with them. Which, of course, leaves us with one last fascinating question for the future. For over a decade and a half, CUDA has been the undisputed king of this world. But now, you see competitors like AMD and Intel pushing hard with their own open-source alternatives, trying to build a bridge for developers to come over to their hardware. So what do you think? Is NVIDIA's CUDA kingdom just too powerful to fall? Or will the walls of this proprietary empire eventually start to crumble?